Hey, welcome back. So far, we've created a Northwind-Lite schema, populated with data, and written some basic server-side functions. Today, we're stepping it up. We'll explore advanced Postgres functions using window functions, JSON aggregation, and rolling totals, all live in Neon. These techniques are perfect for reporting, dashboards, and analytics in a cloud database. Let's start with Windows functions. Windows functions let us calculate values across related rows without collapsing the result set. That's the key difference from a group by. Each row keeps its identity, but it can still see other rows around it. This is what makes window functions so powerful for analytics. You can rank rows, calculate running totals, or compare a row to the previous or next row, all in a single query. In reporting and dashboards, this is how we answer questions like, where does this order rank? Or how does today compare to yesterday? Instead of running multiple queries or doing this logic in an application code, we let Postgres do it directly. Next, let's talk about JSON aggregations. JSON aggregation functions allow us to transform relational rows into structured JSON documents directly inside Postgres. This is especially useful when we're building dashboards or APIs because the data often needs to be nested or grouped in a way that doesn't match the raw data structure. Instead of returning dozens of rows and reshaping them later, we can return a single JSON object that's already formatted exactly how the front end or reporting tool expects it. This reduces application complexity, improves performance, and keeps the data logic close to the database. In other words, Postgres becomes responsible not just for storing data, but the shaping of it. Finally, let's look at rolling totals and time-based analytics. These techniques focus on measuring how values change over time, which is at the core of most business reporting. Rolling totals allow us to calculate metrics like a moving 7-day total, month-to-date sales, or year-to-date revenue. What makes this powerful is that we're not just looking at a single point in time, we're looking at trends and momentum. Postgres handled this by combining time-based ordering with window functions so each row can see a defined range of previous rows. This is exactly the kind of logic that dashboards rely on to show growth, performance, and patterns over time. In general, these techniques let Postgres do the analytics work, not your application. So, in this episode, we'll build 3 advanced functions to showcase these techniques. We'll create the function getTopProducts, which takes on a limit parameter, and this will be used to show top selling products by quantity across all orders. Then we'll create the getEmployees rolling sales to show cumulative sales per employee over time. And finally, we'll create the getCustomer orders JSON, which takes on a customer ID parameter. And the purpose of this will be to return all orders and their items for a customer as JSON. So if we return to the Neon console and then go to our SQL editor, we'll start by creating our first advanced function. We'll type it in here. Let's expand our window here so we can see it clearly. And this function again is purpose is to calculate top selling products. It takes an integer parameter called limit, and we aggregate quantity across all orders. Limit allows us to return only the top end products. Windows functions aren't needed yet, but this introduces aggregation for reporting. So if we run this to create this function, click the run button, and it was created successfully. We can quickly test this by running the function. We'll clear our window here. We'll do a basic select statement on the function name, passing it the limit of 3. So this should return 3 records. And if we hit run, as you can see, we have our data here, product name and a total quantity. And we did limit it to just 3 records. And what we're seeing here is basically the top 3 products sold, all executed in the cloud without exporting data. Next, we'll create the next function, get employee rolling sales. So let's clear our window, type our function, expand the window. And this basically showing cumulative sales per employee over time. So here's what you call a Windows function in action. The sum over partition by order by calculates a running total per employee. This is essential for performance metrics, dashboards, or rolling sales analysis. Cloud execution in Neon makes this scalable even for larger data sets. We can also demonstrate this by doing a select on that function, but let's run that function first. And it's executed successfully. Let's do a select on that function. So select star from the function name, run this, and you'll see data. What you're seeing here is the cumulative sales per employee over time. No manual aggregation is required. Next, we create our get customers orders JSON function, which takes on a customer ID parameter. So let's clear this and type out code. And the purpose of this function is to return all orders and their items for a customer as JSON. And it demonstrates JSON's aggregation in Postgres. Each order becomes a JSON object within an array of items, useful for APIs or feeding front-end apps directly. Neon executes this efficiently in the cloud. So let's run this. And it ran successfully. And to demonstrate it, we can do a select on the function name. So let's clear our menu and do a select on the function name, passing the parameter of 1, which is the customer ID. And if we run this, we'll get a JSON formatted output, which is a representation of the customer orders. This is perfect for applications, dashboard, or REST APIs. And if you're not familiar with JSON, this is what the output usually looks like. And REST API usually depends on this kind of output format to manipulate data. We can do quick verification and testing of all three of these advanced functions, passing different parameters where necessary. If we were to run these three versions of the advanced functions, click run, and as you can see, we have the different outputs here. Here's our JSON coming from our customer orders JSON. Is the cumulative sales return based on the employee rolling sales function. And then our top 5 products, because we're passing in 5 as the limit, so we'll get 5 records returned by top products. Notice how our Neon handles all queries in the cloud. No client-side processing is needed. Advanced functions like these are key for reporting, analytics, or building APIs around your database. And that's it for episode 5. We've now covered advanced Postgres functions, aggregation, window functions, and JSON, all in a cloud-hosted Neon database. In the next episode, we'll look at optional enhancements and best practices for Northwind-Lite, adding extra columns, constraints, and tips for working in Neon's cloud environment. And as a quick reminder, don't forget to like, subscribe, and hit the notification bell so you don't miss any episodes in this series.